Hello, Honors Algebra, Mr. Lawrence here. Sorry about this lesson not being posted a day sooner. I got really busy, had to get home. Anyway, I'm posting it now. Hopefully you still check it out. All right, we're going to go through this chapter test. Quick review. We're going to start with the first problem is to solve a system by graph. Remember, to solve a system by graphing, or to solve any system, we're actually trying to find a place where two lines intersect. All right, so I'm going to go ahead and do problem number 3 from your homework. I believe it said that x plus y equaled, oh no, it's 4y equals 5, and then negative 2x plus 3y, negative 2x plus 3y equals 1. Okay, and I tell you what, I'm going to change this one to blue if it'll let me, so that it can look a little different, so you know which one I'm talking about. There we go. All right, let me see here. I'll do the red one first. Let me take a look at it. I notice it's in standard form. I think that the x-intercept is super duper easy to find. I know the x-intercept is found when y is 0, or the shortcut could be c over a. C over A. A would be 1, so my x-intercept would be 5. 1, 2, 3, 4, 5. Yeah, I plug 0 in for y, I get 5 out for x. Now I know my slope is negative a over b, so I'm going to take the 1 from in front of x, the coefficient on x, make it negative, and use 1/4. So I'm going to go down 1 and write 1, 2, 3, 4. And of course I'll go up 1 and back 1, 2, 3, 4. Up 1, back 1, 2, 3, 4. And I did a couple extra points because I'm hoping to get lucky. I'm hoping by counting slope, I'm going to end up with an exact place where they cross. Of course, we know by solving a system, they don't have to cross at pretty numbers. No, they don't. All right, properties. I'll make the line orange, and I'll change the beginning, and I'll make it just a little bit thinner. All right, there we go. Now I'm going to look at the blue one, and the blue one doesn't look as friendly. I'm not seeing an x-intercept or a y-intercept being super easy. I am seeing the slope of the blue one will be 2/3, but it looks like my x-intercepts and my y-intercepts are going to be fractions or uglies. So I'll tell you what I'm going to do. I am going to find the x-intercept only because I'd rather deal with a half than I would with a third. It's easier for me to graph a half, that sounds cool, graph 1/2 on my graph over here than it is for me to graph 1/3. I can be more exact with it. So I'm going to go ahead and do the x-intercept, and again, that'll be c over a, so that'll be 1 over negative 2, so that'll be negative 1/2. So the x-intercept is going to be at negative 1/2. Now, my slope is 2/3, so I'm going to take that point, let me clone him, and I'll rise 1, 2, and I'll run 1, 2, 3. And notice I'm still in the half range. Now I didn't get lucky. It doesn't look like my my points are going to, or my lines are going to intersect at a point that I know the exact coordinates. But that's okay. The directions do say to round to the nearest 10. So let me draw my line here. This will be my blue line. 1, 2, 1, 2, 3. Right about there. Oh, man, that's close. I can't tell if that crosses exactly where I think it might. It looks like it might be crossing at 1, 1. But I'm not 100% sure about that. I'm not 100% sure. It looks like it might be crossing at 1, 1. I could do a little check. I could do two things. I could stick 1 in for x and see if I get 1 out for y. Well, in the red one, I sure am. I'm going to get 1, 1. If I stick 1 in for x, I'm going to get 1 plus 4y equals 5. 4y will end up equaling 4. Y will equal 1. If that happens with the blue equation, then I know for a fact my points cross at 1, 1. But because I'm at the half, and I'm not sure I did it exactly right, I'm not convinced. All right, so I'll stick 1 in for x, and I'll get negative 2 plus 3y. That'll equal 1. 3y will equal 3. Oh, look at that. Y will equal 1. They do cross right there. There's no guesswork involved. That was too cool. All right, that is solving by graphing. All right, now hold on one second here. I know you folks love story problems, so I'm going to do a couple of those for you. Number 5 from your chapter test. It takes 3 hours to build an armchair and 2 hours for a side chair. Finishing an armchair requires 2 hours, while a side chair requires 1 hour. 1 hour. There are 18 hours available for building and 10 hours available for finishing. Set up and solve a system of equations to determine how many of each chair can be made. Now, when I first read through this problem, it seems a little confusing, so I read it more closely a second time, and I notice that 3 hours is just to build the chair, and then I need 2 more hours to finish it. So to get it complete, and finishing doesn't mean to finish building it, it means to put a finish on it, almost like a paint, to sand it down and then stain it or something like that. Okay, so don't let that confuse you. So let's see, what kind of chair do I have? I have an armchair. So my armchair, okay, it takes 3 hours to build it, plus how long did it take to finish? It looks like it's going to take 2 hours, okay, to finish. So the armchairs take 5 hours to have a finished product for the armchair, right? Now, what's the other kind of chair here? Okay, the other kind is the side chair. Oops, I'm not in right mode. The side chair. And if I remember right, I believe that's 2 hours to finish, to build it, and then 1 hour to finish, for a total of 3 hours. Okay. Now, we need to know the number of hours, the number of chairs of each type that we can get done in each type. So, let's see here. First, I'm going to write an equation for the building, and I'm going to let A, I should make that in black, pardon me. I'm going to make that in black. So let A equal the number of armchairs produced. And then S is going to be the number of side chairs produced. Now, I noticed on your last test or on the final, a lot of you weren't defining your variables. If you're not getting these problems right, please start defining your variables. You see me do it all the time. Imitate what I am doing. Okay, so I know that for every armchair, it takes 3 hours to build it, right? So that'll be 3. Oh, I'm not in right mode again. That'll be 3A. And 2 hours for every side chair. And the total time for building, where is it at here? There are 18 hours for building. So that's got to equal 18. Okay. The number of armchairs I build and the number of side chairs is the time it takes to do both those things cannot be more than 18 hours. Why? Because that's what the story said. Now to finish the chair, well, it's going to take 2 hours to finish an armchair. Okay. And it's going to take 1 hour to finish a side chair. I say side chair for the first one is 2 hours for an armchair, 1 hour for a side chair, and the total time there is 10 hours. Okay. Now, a problem like this, I don't think I would graph it. 1, I don't like the fact that I don't have X and Y. 2, it's screaming at me. It's saying, hey, elimination would be pretty simple here. So I'm going to go ahead and use elimination, and you can count this as to how to do an elimination problem. So I can keep this video a little bit shorter. I'm going to multiply this by -2. I'm going to multiply the 10 by -2. Why am I multiplying it by -2? Because I am trying to get this to be a positive 2s, which it is, and this to be a negative 2s. So I'll multiply it by negative 2. Remember, the coefficients have to match, but have opposite signs. On the midterm, some of you were like writing down 12a plus 12a and then crossing them out. 12a plus 12a is 24a. It is not, does not cancel out. It's not 0. All right, so I'm going to distribute over here. Well, I'm going to rewrite that first equation. So that's 3a plus 2s equals 18. And then after I distribute, I'm going to get a negative 4a, and I like that, minus 2s. That's going to equal negative 20. All right, I'm going to go ahead and add, and I notice these will cancel because the signs are different. This will turn into negative a, or negative 1a, and over here will turn into negative 2. A, therefore, will equal 2. Remember, I can't just change the signs. I either multiply through by negative 1 or divide by negative 1. So it means I have enough time to produce one armchair, or two armchairs, excuse me. Now that I know that, I'm going to go up to this equation, 2a plus s equals 10, and I'm going to substitute in the 2 for the a, and that'll be 4 plus s, and that'll equal 10, and then s will equal 6. So my best answer, you can produce 2 armchairs, and where did I come up with 6 side chairs? 6 side chairs. All right, so we got 2 birds with 1 stone there. I did an elimination problem, and I did a story problem for you. Okay, I'm going to try to keep this to 15 minutes, so I'm going to do one more problem for now. Okay, the next problem I'm going to do is going to be problem 26, but before I do that, I'm going to mention something really quick. Problem number 27. When you set up your equation, remember, you're going to have something like d plus n equals 30 will be one equation. But when you have an equation that equals the $2.35, that won't be d plus n. You need the value of the dime, 0.10 times d, plus the value of the nickel, which is 0.05. So the correct setup for problem 27, you'd have d plus n equals 30, then 0.1 or 1/10 d plus 5/100 or 0.05 n will equal $2.35, $2.35. That is the correct setup. Okay? Alrighty, so let's go through problem 26 here. Xavier and Yolanda earned at least 100 points in a contest at school. Yolanda earned at most 20 points more than 5 times Xavier's points. Set up a system and solve for a statement. Okay, first thing I'm going to do to find 0. So I'm going to let x equal Xavier's points. It doesn't equal Xavier. It equals his points, the points that he earned. Okay, and Yolanda, y is going to equal Yolanda's points. Okay, so there's my 2 variables. All right, now, Xavier and Yolanda earned at least 100 points. I believe that means together. I believe it means together. So x plus y is going to have to be greater than or equal to 100. It could be equal to 100, but it says at least 100. There's my first equation. Bam! All right. Yolanda earned at most. Yolanda is at most. So Yolanda is going to be less than or equal to 20 points more than 5 times Xavier's. Well, Xavier's points are x. 5 times Xavier would be 5x. 20 points more would be plus 20. I have to take Xavier's score, multiply it by 5, and then add 20 to it to get the second equation. All right. Now, a problem like this, it says to solve by graphing. And so before I do that, no, this is a good one. I can do that. I think I'm going to get them both in slope y intercept form just to make it look simple. And so I'll convert this one here and I'll turn it into y is greater than or equal to negative x plus 100. Okay, and that's going to be kind of weird. My y-intercepts are going to be 20, but my slopes, oh my goodness, it's going to be a challenging one to graph. So hold on, let me get some good graph paper. Okay, this isn't going to be a difficult one to graph, but I had to think about it for a minute because I was noticing I was going to have a y-intercept of 20 and a y-intercept of 100, but a slope of only 5 and a slope of -1. But I also thought, you know what? For my slope on this one, if I count by fives, I could think about my slope as, you know, -5/5. And that's the same as -1. My slope here is 5/1, but I might want to think about that since I'm counting by fives. I might want to think about that as like 25/5. Just blow my slopes up, so to speak, and then I'll be able to deal with these. So I'll tell you what, I'll graph this one here in red. And I know my y-intercept is 20. And please note, I am counting by fives. 1, 2, 3, 4, and then I hit a 20. That means each line is 5. So my y-intercept is 20. I'm counting by fives, not by 20s. There's my origin. Okay. And my slope is 25/5. So let me see here. I'm going to go rise 5, 10, 15, 20, 25, run 5. 5, 10, 15, 20, 25, run 5. All right. I think I have room to do one more. 5, 10, 15, 20, 25, run 5. There we go. So now I can draw that line. And it's going to be a solid line. And I'll make it red. So I'm going to start here at the y-intercept. And notice I'm not going to make that line go forever in the other direction because it's impossible to get scored less than 0. So contextually, it just wouldn't make sense to do that. All right, so the orange line represents the top equation. The second equation I'll do in blue. Okay, the y-intercept is 100. And then it looks like I'm going to go down 5/5. Remember, that's what I said. So I'm going to go down 5/5, down 5/5, down 5/5, down 5/5, down 5/5. Now, I actually forgot to do my shading, didn't I? So I'm going to go ahead and test that orange one before I shade, before I draw the next line. And I'm going to put the origin in. So I'm going to put 0 less than or equal to 0 plus 20. That is a true statement, so I'm going to shade where the origin is in relation to the orange line. And that would be on this side, right? Yeah, it's going to be beneath it. So I'm going to shade all over here. Okay. There we go. Sorry, this is running over, folks. Now, I'm going to shade, I'm going to draw this one. It will be a solid line. And it's going to go like that. Okay. And I got to decide where to shade on that one. So, again, if I put the origin in, I'll get 0 is greater than 0 plus 100. That is a false statement. 0 is not greater than that. So I will shade up here. And notice the green region is where my solution is. And of course, that green region is going to extend all the way out here with only the x-axis and the line with the negative slope being its boundaries. So it's all here is all green. All right, so there you go. I solved the system of inequalities by graphing. I had to write my own system. All right, again, sorry this ran over a few minutes. Hope you have a great long weekend. Just so you know, I'm probably moving the test to Friday, actually. All right, Mr. Lawrence signing off. Good night, everybody.